Hello friends, welcome to Joy of Life. So today we are going to have the 12th episode of System Design Fundamentals. And before we begin, I would love to thank you all for all the love and support for the channel and taking the channel to the monetization. The channel has started earning its own income. It has made around $1,000 till now. But that's not the whole point. The whole point is the love and the support the channel has received in the last 1 year and 4 months. I never thought that I would be able to make it to monetization. The kind of love and support that you guys have shown is tremendous. We are having 2500 plus members at the moment, and I have extended the support as well and created some membership in case if you're interested. Do join me in the membership part. There are various tiers. I have named them as order of n, order of login, and order of 1. So each of the level has its own perk. It's very cheap. It's just rupees 89 a month. So here you can have mock interviews with me. You can have collaborative reviews of system design, coding interviews, and the interview preparation and all that. If you're looking for extended support, please join the channel. So once again, thanks to all of you for making this a grand success. I never thought that this channel has the potential to make it. And thanks to all of you who has taken your time out to comment. So it was really nice to hear from each one of you, get to know your thoughts, and to connect with some of you personally. It was really great. I'm looking forward for more collaboration down the line. As my routine started getting a little more busier, I'm not very frequent with the videos, but I make sure that I take out time to create new videos, and I'll continue to do so. We'll start a new series on the coding as well. But before that, let's continue with today's episode. We are going to talk about the communication in microservices. We'll talk about all the patterns that exist in microservices communications. So with that, let's start. So here is a very basic scenario that you see over here. So we have some client like a mobile or a laptop, and we make a call and we get a response, right? So these kind of calls and these kind of communications is called a synchronous communication. We have seen basic example using HTTP calls, right? We make a call, we get a response, and we wait until we get a response, right? So these kind of calls are called synchronous calls. In this kind of call, the data is moved from endpoint to endpoint. So a request is sent from the client to the server. So in this case, the mobile is the client and the catalog service is the server. So we make a call until we get a response, we wait for it, right? So it becomes a blocking interaction. So typically we see this kind of communication using the HTTP request and response. So until we get a response, we wait for the call to finish. So these kind of requests takes very low time, maybe 1 second or even lesser than that. So if you open, let's say Amazon.com, and you go to the network tab, so you can see all the requests that is made by the page, right? So as I click on say today's deal, you can see that there are tons of calls that are made. Some of the calls are definitely for loading the static content, but there are a lot of calls which is made to get a response. So if you see on top, we have selected XHR calls. So XHR is mostly the calls that we make to get some response. Of course, the other calls is also to get the response like images and all. But if you take any call, let's say watched, in some cases you might not see a response, but in some cases you will see that there is a response. So if you see this response, if you just take this to a JSON formatter, you'll be able to see that that call has responded with this result, right? So these are nothing but HTTP calls. So if you see over here, these are nothing but your HTTP calls, which has immediately given me a response. And if you see the time taken by them, it will be very low. So you can go to the timing and you can see that the total time taken by this call is about 1.31 seconds. But it is split up into various stages. So you have some SSL handshake, you have some initial connection time, DNS lookup, stalled for some time, queuing. So this is the actual time TTFP taken for processing the request. The other type of calls that we have is asynchronous calls. Asynchronous call is one in which the request to the service and the subsequent response occurs independently, right? So over here we saw that we sent the request and we waited and the response came, right? But in a asynchronous messaging, the response might not occur immediately. So we place a request and we leave that request. So the request gives me a 200 OK and says, okay, your request has been accepted. But it will not give me the actual response immediately. For example, let's say I wanted to download a file. So I go to my bank website and place a request that, okay, I need the statement for the last 6 months, right? To compute the statement for last 6 months, there are several transactions. It would take time. So the call will respond me with a 200 saying that, okay, I have received your request and will let you know once your download is ready. So let's say it's a download service. So we place a request and this request responds with a 200 OK. So what will happen is your request has been taken, but your processing is not done. So your request is maybe parked somewhere else. Where it is parked and how can we do it, right? So in these cases, what we'll do, we'll have a queue and your request will be placed inside the queue. And as soon as it is placed inside the queue, you are responded with a status OK, saying that your request has been accepted, but it's not processed. It will be processed later sometime. So what will happen in this case, we'll have another service. So we don't call them service. So it does not have an endpoint. So this is more of a worker. So generally workers are the one that listens to some of your queues. So we have a queue over here. So this is my queue. So this worker over here listens to all the requests that comes into the queue and it processes the request, right? So this worker picks up your job. So you have created a job basically. So for you, a job has been created and it was added to the queue. So your job is standing somewhere here in the queue. So not only your job, all the requests that will come in will be placed as a job. So this will have a lot of jobs inside. So this worker will take the job, it will do all the required processing, and what it will do is it will generate the report for you and it will put the report in some file server. So let's say this is my file server and the report is generated in a CSV format or whatever format. Maybe it's a zip file. And what it does is it takes the zip and puts into the file server. So this is where my report file server. And what it does is it goes to the database. So let's say we have a database and it updates the path over here. So we know for this particular job, we have updated the path, right? And when the client now requests it, what will happen is the subsequent request for the client will go and get the data from the database. So initially what when the request came, it has updated the database with the status pending, and he has done the job and updated it again with the status saying that it's done. We can have a service also in between. We might not have a shared database between two of the service. We can have a completely separate service who takes care of the database, so that we call the endpoint. So rather than saying that we call the DB, we can say that we have a service and we call the service. So rather than saying that we call the DB, what we can say is that we invoke this service with the status. So we update them with the status. And what happens is the client the next time sends a request to this guy to get all the download status for him, right? And it gets the status saying that, okay, it has been done, the work is done. So this is how it goes. So the communication between them is asynchronous. You don't know when your job is going to be picked up and when you are going to get your job done, right? So the worker will also have an arrow over here. So it does, and it updates the path. It sends the path in the response. So for a simple scenario like this, we can get it done using a simple queue. But in general practice, what happens is for implementing asynchronous microservices is to use a message broker, something like a Kafka or a RabbitMQ. So this is the second type of communication we have in our microservices. Now in messaging services like Kafka and all, what we can do is we can create topics, and each of the topics will have its messages, right? So for example, take a scenario that where we need multiple topics for communication between multiple services, right? So in those cases, what we do is we generally create a topic for each one of those communication. So let's say I have ordered some item and I wanted to do a billing, right? And when we do a billing, we need to inform the inventory that we are doing a billing and those items need to be delivered, right? So as soon as we are billed, we need to communicate with several other services, right? So billing need to contact inventory, billing need to contact notification, billing need to contact cart. So a lot of calls has to be made, right? So once we are done with the billing, we know we can get them done asynchronously. Let's say this takes around 4 seconds, this takes around 6 seconds, this takes around 5 seconds. So I should not make my customer wait 15 seconds in order to finish those tasks, right? So as soon as I am built and I know the things are available in the inventory, I don't need to make them wait, right? So what I'll do is I will take them asynchronously. So I will have separate queues for each one of them, right? And I need to just put a job inside it in order to say that, okay, I don't need to wait. I can process it asynchronously and I can just get it done. And each of them listening to this queues can pick up the job and get it done, right? Now it becomes tedious that we create so many queues, we need to maintain so many queues. So many queues might have infrequent jobs, right? Things becomes tedious over here to maintain, so we don't do it like this. So what we do is we create a message broker. So let's say this is our message broker, right? So he's the one who knows that, okay, I have created certain topics. So this message broker deals with the messages. So it takes a message from billing, says that, so the billing says that, okay, the billing is done. So the message will have a topic. So let's say I'll create a note over here saying that this is my billing. So this is a topic. So whatever job that comes from billing, whatever job comes, it comes and we put it to the billing. And these guys over here, it subscribes to a topic and billing is a topic. So these three guys need to know whenever there is a billing. So he subscribed to this topic. And all of them consumes this message and handle it in their own way, right? Similarly, we will have other topics as well. Suppose the billing is done and there is a cancellation request that comes in. So it will also hit the billing service, right? But in this case, we'll have a cancellation topic. So we'll have a completely separate topic and let's name this topic as cancellation. And the billing service, once again, will call the message broker and say that, okay, put a task in the cancellation. So the cancellation is added over here. So the notification guy needs to know that there is a cancellation and the inventory guy also need to know that there is a cancellation. So what has happened, these two guys has subscribed to this topic as well. But my card does not need to know that there is a cancellation that has happened because he doesn't care about it, right? So what happens is he does not subscribe to this topic. So when a cancellation occurs, the notification and inventory is notified that, okay, the cancellation is needs to be done and the cancellation will be processed by these two guys. So probably we'll have another service over here called cancellation. So this is just an example we might not have. So we will have a cancellation service who takes care of the cancellation. So he will also subscribe to this one. He doesn't need to know the billing thing, right? So here you can see that there is a cleaner separation between your producer and the subscriber of the messages. So we can keep the system pretty clean and we can process them independently, not at the time when the message comes. We don't need to do it immediately, right? So just think of a scenario that today I have a new service that has come, right? And it's a dispatch service. So it checks for the dispatch and all those things, right? So he needs to know that whenever there is a billing, he needs to get in touch, right? So if we go with a normal approach, the billing was calling three of the services. Now it need to call the fourth one. So as soon as the dispatch service came to life, we are touching the billing service again, right? But in this approach, we don't need to. As soon as this service comes up, we just subscribe to this topic. So there is no change that we need to do in this billing service. So you can see that we have a very cleaner separation over here. We don't need to change the producer of the message, right? So producer and the consumer of the message can exist independently and we really don't need to care about how things are going. We can create as many topics as we want and each of the consumers will consume it in a different way. So you can just think of a scenario that cancellation service tomorrow needs to inform the dispatch service also, right? And it has to stop the dispatch if it hasn't done. So in this case, what will happen is you have to just subscribe to this topic, nothing else. So as you get that message, you just need to process it yourself. So the things become very simple and the separation becomes very clean. So this is also called the event driven architecture. So everything over here is an event. So these events are fired. So these are the events. So cancellation is a topic and there are events inside this topic, right? We're going to see when we dig deep into Kafka. So basically Kafka will create a lot of topics, and each one of these topics will have messages. These messages can be played, replayed back, replayed from a certain date. You can do so many things, right? You can start consuming from the latest message, you can start consuming from the historic or the first message itself. You can have several ways in which you can consume these messages. So if you remember the hands-on series that we have done earlier, we have done to certain extent, we have used Kafka, we have created several topics, and we have seen how the message can be consumed. So if you wanted to check on the same, go to this system design mini project wherein we have worked with Kafka. So we have created Kafka Docker container. We have configured Kafka. So we have run it locally, and we have started. We have produced and consumed message, configuring and running both Spring and Kafka from Docker. Then creating Kafka consumer. So we saw how we are producing the message and how the same was consumed. You can see that we have produced messages youtube.com, it was coming. So these was nothing but our messages for a particular topic. So we have created multiple topics and we have ingested the messages, we have consumed the messages, and we have processed the messages as and when they came. So do go through this episode once. Since you got a basic learning, you can just go through the episode to get a better hang of it, and definitely it will give you a better understanding of what a message or what event driven architecture is all about. So it was just a stepping stone towards the event driven architecture, and in the days to come we'll see how the event driven architecture can be leveraged to come up with different kind of solutions. So just to give you a brief, so generally the services that has an endpoint, API endpoint, which can be invoked are called services. And in these cases where we don't have an API endpoint, but we consume from a queue or from a message broker, they are called workers. So the workers do not have a API endpoint to call you, but definitely you can have both the API endpoint as well as listening to the messaging queue or message broker. So there is no harm to it. So there is no problem. You can definitely go ahead and configure a service, and those kind of services are generally called hybrid. So in general, a hybrid microservice is one that supports both synchronous as well as asynchronous interactions. So those kind of service will generally have your messaging protocol as well as your HTTP support. So in the episodes to come, we'll see how the transaction can be handled using event-driven architecture. So in microservices, as you understand, the transaction spans over multiple services, right? So there is something like a 2PC, 3PC, so two-phase commit protocol, three-phase commit protocol. So we are going to understand how all of them works. We are going to understand about the saga pattern. We'll discuss more in details in the next episode. We are going to see how it's going to help using a event-driven architecture, though they are a little complex compared to the normal HTTP call. But event-driven architecture, as we see, can have a much cleaner separation between the services. So in this case, you see that these two services need to coexist, right, in order to get things done. But here, if you see that if the notification service is down, the billing service doesn't care. He doesn't know that the notification service exists in the first place, right? So in this case, over here, we named it board download. So let me change this. So in this case, if the download manager is down, download service is impacted to a great extent, right? You cannot get the information from it. But whenever you make a direct call, what you do is you create a dependency between them. So here the download service was calling the download manager service, right? So if this download manager service is down, so there is a problem that he will fail, this call will fail, and we need to have a fallback plan. But here, if any of these services over here fails, a billing service does not care about it, right? What it does, it will just go ahead and put a job in the queue and it will say that the work is done. he doesn't care, neither does he know that they exist, right? So they will come up in some time, pick up the job and get things done. So the segregation is cleaner, the coupling is almost not there, and it's really a good thing, right? So yeah, in the days to come, we are going to see more in details about the event-driven architecture. It's going to be a big piece. So yeah, in the days to come, we'll discuss in much more detail. So that's all from this episode. Do let me know what you think about this episode, and do leave a comment. So it always feels great to have your comment. So yeah, please keep commenting. Please keep motivating the channel. Please keep showing the love and support for the channel as you have done earlier as well. And yeah, thank you once again for taking the channel to the monetization. It really feels great. Have spoken to some of you personally as well, and it really feels great to interact with each one of you. It's not that I have taught you things, but I have learned a lot of things from you, and I hope to do so in the days to come. It takes a lot of time creating these videos and to share, so pardon me for all the delays in the creation of the videos, but yeah, it has been a fantastic journey, and it's been great knowing each one of you, hearing from each one of you. It really amazes me the kind of love and support that you guys have shown in the channel. So once again, thank you, take care, bye bye, and we're definitely going to have more episodes in the days to come. So yeah, see you soon, bye bye, take care.